Those are some pretty sweet moves. Kind of reminds me of me, but we'll get to that later. I'll be your video instructor today, and today we're talking about matter and materials, the states of matter, which I'm told you all know to be a solid, liquid, and a gas. Oh, excuse me, boys and girls. I'm pretty thirsty. I gotta take a sip of the soda I have here. This soda makes me think. In my hand right now, I actually have matter representing all three states. Can you tell me what that is? Or exactly how they arrange themselves? Tell me what state the glass bottle, the drink of soda, and the bubbles are in. Yeah, I see many of you correct. The bottle is a solid, the drink of soda is a liquid, and the air bubbles are the gas. Now the air bubbles are the toughest one to get, but I can show you by shaking the soda up a little bit and then opening it slightly. You hear that? That's the gas escaping from the bottle. Okay, we're gonna build our story today using questions submitted by students just like you. And they are, what is matter in the three states made of? Great question. What exactly is a state of matter anyway? How does matter change from one state to the other? Is each state of matter a completely different kind of matter? And what other solids, besides ice, can be turned into a liquid? I'm interested to find out. The first question is, what is matter in the three states made of? Well, here we have a diagram that helps us out a little bit with that. We have a photo of water, and then if we could zoom in a billion times, this is what water would look like. It's made of water molecules. The molecules are these particles, these building blocks for water, and then each molecule is made of three different atoms. So atoms are the smallest divisible unit, which build to make molecules, which then make the water. Now the key is that different types of molecules in atom make different types of matter. These ones happen to make water. Let's take a closer look at what this might look like.
How many molecules are in a single drop of water, or a single cell? Let's fly in and find out. This may look realistic, but it isn't. You're only seeing about 1 out of every 1,000 water molecules. Here's how they look at full density. Into perspective, think of a red blood cell, which is about 7 microns or 7 millionths of a meter in diameter. More than 140 red blood cells laid side by side could fit into a single millimeter, and yet the volume of each cell could hold about 3 trillion water molecules.
Three trillion water molecules in each red blood cell. That's how small water molecules are. Okay, that leads me to my next question. I think you saw on the last slide, or maybe some of you noticed, the symbols H2O. I'm wondering if anybody can tell me what H2O stands for, and that type of matter it stands for, what state is it in? Is it a solid, a liquid, or a gas? Can I have a student representative come up to the mic, please, and answer that question? Okay, you are absolutely correct. H2O stands for water, and liquid water is a liquid. But the thing is, that's not the whole story. H2O also is the scientific name and stands for ice and steam, which are all basically water, but they're water in the different states or phases. See, because the thing is, And that leads us to our next question: what exactly is a state of matter? The thing is that you have different types of matter. So you can have H2O, which stands for water, and you can have CO2, which stands for carbon dioxide, the bubbles in soda, or Cu, which stands for copper, a metal. And within each type of matter, you got different molecules. The different molecules determine what type of matter it will be. But, and if that's not confusing enough, each type of matter can come in 3 different phases. And the amazing thing is they're essentially the same stuff in each phase. They just behave differently. So H2O can be a solid, a liquid, or a gas. Let's take a closer look at the 3 phases or states of H2O. Now, I want you to imagine that we have an ice cube, and we've put that ice cube in a glass jar. And we're going to put that jar over a flame to see the 3 states of matter. I think you can imagine what would happen. The ice cube would heat up, it would melt into water, and if we kept heating it up, it would boil and we'd get steam, the 3rd phase of water. Let's take a look at what this looks like. So here's our flame, here's our beaker, here's some water molecules, and here's our ice cube. You can see that the ice cube and the water are made out of the same stuff, except the ice cube is moving more slowly. But as we heat it up, the molecules start to move more and more. They get a little bit further apart, and then they lose their shape. And now we have all liquid water. As we continue to heat it up and add energy, the molecules get more energy. They start bouncing around. They start bouncing around like crazy. And now they behave like a gas. And we have steam. As we heat up the water more and more, it boils and we get more and more steam. We cause it to change phase. Okay, which brings us to our next question. You just got a very important clue from that video. How does matter change state? And we're going to look at another video that's going to help us answer that. I should note that phase and state are the same thing. So if you hear phase, that's the same thing as state.
Getting things to change phase takes energy. So take a look at this. It's liquid water, and we're heating it with energy from this burner. Above the liquid is water vapor. It's invisible. The molecules get more energy, and they change phase to a gas. See, the liquid is becoming water vapor. It's changing phase into a gas. Now, what if we wanted to change phase again? Like, let's say we wanted to turn this liquid into something else. Like, maybe we want to turn this liquid into a solid. Now, how would we do that? We'd have to take energy away, right? What do you think we'd need? Well, maybe a freezer. Maybe a great big stainless steel freezer of science, like this one. Take a look inside. It's cold. It's real cold. Oh, it's like -4 degrees Celsius. Now, where does the energy go? Where does the heat go that was in this freezer? You can't just throw it away. That would be a violation of the first law of thermodynamics. What? Now, the heat has to go someplace. Well, take a look up here. See that thermometer? It says like 28 degrees Celsius. That's warm. That'd be like a very warm summer day. So what the freezer does is pump the energy, pump the heat from out of the freezer into the room. Now, if you can do that enough, you can make things change phase. Take a look at this. It's a great big